Welcome to join this consultation webinar on the diversity and inclusion. Actually, today's seminar is also related to the engineering education. We are going to further make consultation on the graduate attributes and professional competencies framework, which is proposed by a joint working group of WFEO and IEA. But today's webinar, we are going to emphasize on the diversity and inclusion, especially the gender equality. Because as you know, when we talk about sustainable development, gender equality, inclusion is as important as clean water, clean energy, and many others. So today we are going to invite 7 speakers to give their speeches at first and then have some time for questions and answers. Before questions and answers, we are going to ask you to give your questions on the Google Doc or using the chat box. We have a guideline for the participants. Please see that guideline and use the chat box and the Google Doc to pose your questions. Now, please allow me to start the webinar with the first speaker, Peggy Oti-Boateng, who is from UNESCO, is the head of the Office for Capacity Building. She plays a very important role to support engineering scientific organizations to work with us together, support the collaboration between WFEO and IEA on the review of the framework of graduate attributes and professional competencies. So please, Peggy.
Thank you very much, Engineer Professor. Thank you all for, let's see, share. Can you see my, is it sharing? Can you see it? Hello? Can you see my screen?
Yes.
Yes, we can see it.
All right, okay. So I should put it in the, all right, okay. Thank you very much, colleagues, again, and thank you for this opportunity to be with you. It's always a pleasure to be with colleagues, and also, especially because we're talking about engineering. And it's really at a very good time. And just to give you something from UNESCO, we are at the stage of developing our medium-term strategy for the next 8 years, from 2022 onwards. So these discussions are very important, for us as we shape, the next agenda, for science, technology, engineering, and mathematics education. We at UNESCO, again, to give you some background again, we are at the heart of all the SDGs, and engineering is clearly at the heart of it. UNESCO tries to build peace in the minds of men and women through education, the sciences, and the culture, and communication information. And we've been doing this for the last 75 years, and we have walked the journey with WFEO for the last 50 years. So thank you very much. Very great opportunity. But the new paradigm that we're also looking at is open science, open data, open information, open engineering. And this is very critical, especially at this time when we want to bridge the knowledge and the gender divide. So this meeting or this webinar is very, very key. We're also looking at this stage addressing the challenges of socioeconomic development, we're looking at innovative solutions. And engineering is, the profession, provides innovative solutions. But we need innovative solutions which are efficient, transparent, vibrant scientific engineering communities can access it. And eventually, we have to make it work for society such that we don't leave anybody behind. And I would like to, again, take you back to the new discussion that we're also having, that we need to make science and engineering open to society. But we also need to develop that data, that information and knowledge, technology. We need to have evidence-based decision-making policies. We need to have standards for governance, and we need to close that gap. So as we look at this consultative meeting on developing a graduate attribute and professional competency framework, this should also be our guiding principle. And now I go directly into how UNESCO has been able to do this or is doing this, and would like to call again on continuous collaboration from WFEO in addressing the two main priorities of UNESCO. In the science, science, education, culture, and the communication information, we are looking at two main priorities. That's priority Africa and priority gender. So as we develop these attributes, we would want to, WFEO to work, along with us. And we have been doing, some of these, but we're not there yet. I'll just give you a bit of a background. That women and girls continue to be excluded from participating in science, even let alone engineering. And according to the study, by 14 countries, the probability that female students graduating with bachelor's in degree or master's or doctors in science or science-related fields are 18% at the graduate level, 8% at the postgraduate level, and only 2% at the doctoral level, which means that the percentage of girls who go into these, science and engineering gets even lower and lower. And it's even worse still when you look at, lifelong. You can see the leaking pipe. We have, in general, taking all graduation of bachelor degrees together, you can see that 53% start, then it drops off 53%, well, we'll still go there. Then it drops when we have women graduates, and finally as researchers. And the reason for this is that it is very difficult for women to balance between productive and reproductive stages, and a lot of them give up. But as we develop these professional programs, we should be cognizant of this leaking pipe. As women grow older, as they get into the productive and the reproductive stages, we need to address this particular instances of women. That's why UNESCO, is involved in, again, mentoring women from all over the world. And this is a data which, I share with you. But we still find that it's even worse depending on regions. And I think China, is doing very well. But when you come to Africa, it's quite low. When we, and we are promoting L'Oreal fellowships for women in science. But when we come to the physical sciences, that is the mathematics, the physics, the chemistries, we still don't have many women. And again, as we develop these curricular professional programs in chemical engineering or, mechanical engineering or ICT, those hack or electrical and electronics engineering, we should be conversant of how we can mentor women, to be able to do this. It's not because they cannot do it, but because, of the stereotyping that, these physical sciences or engineering is difficult. So we also need to address that. So we have this program of Women in STEM, which we've been doing over the years, but we're still not there. There's a real big disparity between countries, a real big disparity between regions, as I've said, and especially even disparity between Francophones and Anglophones and Lusophones, which means English speaking, French speaking, and Portuguese speaking, or any of the other language. You can see a big disparity between that. So we also need to work on that. So I know most of the curricula will develop maybe in the English, but when you come to French, please, or Portuguese, we also have to be conversant, or even in Spanish, we also have to be conversant with. So we have this program, which my colleague Rovani, kindly shared with me, to look at some of these critical numbers, that around 18% of women engineering, but 30% in science. When you look at some of the details in countries in the EU, the average is 16.6%. And Latvia is quite high compared to the UK. And you may ask why. It's because of the national policies. And China has even higher to do with national policies. But even, we would say we have these large numbers. But how do they, translate to transforming, the SDGs? There's a long way now. Yes, we may have the numbers, but there are a lot of them that are not, targeting, transformational change. And the SDGs gives us an opportunity to be doing that. So again, this is an area that we would want, to look at. I think I've, talked about this. When you come to Canada, Finland, it's been, different. So we'll share this with you so that you have some of the data as well. Computer science is the new paradigm, and we still don't have many women in that. Again, this would be an area that we would need to have more women in, because we are in a digital stage. We are in a digital transformation. Digital is everything. We need more women to be in the, the forefront. When you even come to electrical engineering, you don't even have the women in there. Again, these are areas that would want to emphasize. Because we need more women in science, and because we need more men and women in engineering, we have in celebrating days so that we can have this. And on the 11th of February, we usually have women and girls in science. Would want to call on you to help us celebrate that. But particularly, we have now Engineering Day. I was jokingly said we'll have to see you in Paris, which is the 4th of March. Unfortunately, we're not able to do it this year, but I hope that next year we'll be able to do that. And we want you to join us in promoting in this great partnership of engineering, so that we can celebrate it, and make engineering visible, but not only visible to everybody, not only able to bring on everybody, but in particularly women, because in some regions, for example, in Africa, we have 51% of the population being female. So if you don't invest in this 51%, definitely there'll be a big disparity, and definitely we cannot catch up. And that is why we are very interested in this graduate attribute and professional competency-based framework, but in particular, looking at the diversity and inclusion so that nobody is left behind. So thank you very much.
Thank you. Thank you so much, Peggy, and for your comprehensive presentation about the importance of gender equality for engineering development and for the sustainable development to achieve the sustainable development goals. And you have shown the disparity currently in the world, especially in the field of engineering and sciences. So thank you again. And next speaker is Ms. Gail. Gail is the president of the International Network of Women in Engineering and Sciences. That is a very important partner with WFEO to promoting the Sustainable Development Goals, especially the Goal 5. So let's welcome Gail give her presentation.
Good morning. Thank you very much for this invitation to, we see screen? There we go.
Yeah, please.
And we'll switch to presentation mode.
Yes.
Okay, are you seeing the presentation? Are we in presentation mode?
Yes.
Okay, thank you. So, thank you, Peggy, for the great introduction and information about women in STEM. I would like to take a few minutes and introduce you to the International Network of Women Engineers and Scientists and why we're so excited about this opportunity to talk about including diversity and inclusion in these professional competency framework. The INWES is a global network of organizations of women in STEM. We have all sorts of organization members, university members, individual members, corporate partners, representing about 250,000 women from 60 countries worldwide. We were started in 2002 with an encouragement from UNESCO. So UNESCO has been a very big advocate of INWES since we started. So we became an official NGO partner of UNESCO in 2008, and then became granted the Economic and Social Council status for the United Nations in 2017. INWES has a number of functional areas and programs. First, through advocacy in many venues, provide international voice for women in STEM careers, such as at the UN Women and UNESCO events and other international conferences. We provide a quarterly newsletter regarding women in STEM about activities and events worldwide. And we share a lot of research and information via conferences, publications, and collaborations. And we're currently working on a web portal for information on women in STEM. We have worked very hard on establishing relationships with corporations and foundations to support travel for women in STEM to study abroad, to attend workshops, and to present their research in conferences. We're also encouraging the foundation of new organizations for women in STEM for professional development and recognition. Recently, we have helped start organizations for women in STEM in Mongolia and Sri Lanka and Nepal. We also conduct programs and share best practices for outreach to girls and their parents to encourage students' professional leadership development for our members. And we also provide many workshops for schools, universities, employers, and professional associations. So that's a little background on INWES. Obviously, one area we're focusing on is women in STEM. And we all know, and Peggy's also introduced some of these ideas, that access to STEM is one of our greatest challenges facing our society right now. We need more people in STEM worldwide to help with political decision-making right now. Also social progress and overcoming cultural norms. We need more people in STEM to address technology issues such as what we're dealing with right now with sustainable development goals and the pandemic. and it's an economical necessity for all of our countries. If we don't see 50% of the population in universities and the workplace, such as women, then how can we expect them to understand what women want and women need in terms of products and in new technologies and new developments? So women are really essential now in new product development and addressing societal challenges, such as the United Nations Sustainable Development Goals, which Peggy addressed. So gender diversity is no longer just nice to have or for ethical issues, but it's really a necessity for all of our countries and our world. Innovation is vital for companies because they must adapt to changing environment more and more and faster. So we need to get more women into STEM pipeline to help participate in innovation. So this chart has similar information that what Peggy presented, showing the gender gap in the research areas. And you can see it's sort of small here, but it's obvious around the world that women in research and science represent 20% and less in most countries, which is a real challenge for us to include more women in science and research. The need for more women in science goes beyond just issues of fairness of ethics. Our world would be better off with more women in the lab fields. INWES really welcomes the 6 areas of change identified by the IEA and the WFEO surveys, particularly in number 5, which was the diversity and inclusion, to include these considerations within ways of working in teams, communication, compliance, environment, legal, etc. systems. So INWES agrees with embedding D&I in the framework. The expected impact of increased diversity and the culture of inclusion will have an impact on helping achieve sustainable solutions and the UN Sustainable Development Goals, which is addressed also in Change 4, as well as increasing innovation, which is addressed in area of Change 6. Diverse teams outperform smart individuals when the problem is hard to solve. This is a quote from one of many studies that have been done the last 20 years, looking at the importance of diversity and all the different aspects in industry and specifically in engineering and technology areas. One study I've presented here is from the Boston Consulting Group, which did surveys in 2016 and 18. And their conclusions from these surveys was that no ifs or no buts. Diverse companies are more innovative, and innovative companies need to be more diverse. But gender diversity has to go beyond just tokenism. It has to include crucial involvement of women. A survey of 1,700 companies in 8 countries confirmed innovation revenues rise with diversity in 6 different areas. Another study that was done recently by Harvard Business School had the conclusion that where gender diversity is accepted, inclusion, productivity, include innovation, definitely increases. These are charts from another study that was done and includes also notes from the Boston study that innovation performance only increased significantly when the workforce included a non-trivial percentage of women, essentially more than 20% women in management positions. The more high-tech a company, the more innovation matters to its business performance. And when we're talking engineering, we're talking high-tech companies. So finally, I'd like to conclude here that INWES supports the proposed changes in the GAPC on diversity and inclusion. We are supporting this because it will ensure that more women feel included in engineering education, so to fix the number of women in engineering. We'll ensure more future engineers with both men and women in training to value gender equity, so to fix the institutions also. And inclusive design, so that engineering solutions address gender issues, and this is to fix the knowledge issues. So innovation is an outcome also of diversity. As complex and technical organizations, engineering institutions are most likely to benefit from diversity. The complex problems of climate crisis, pandemics are best solved by diverse and inclusive teams. So thank you for providing this opportunity for INWES to share our support of these new framework. Kanji?
Thank you, Gail. And we highly appreciate the collaboration between WFEO and INWES. And I really hope we can form a more diverse team or diverse society of the engineering society, and outperforms the less diverse society and the less diverse teams, as you has demonstrated. The diverse team outperforms than smart individuals. So next speaker, we goes to Professor Bulent Ozguler. Bulent Ozguler, Professor Bulent is the head of the working group, the joint working group of WFEO and IEA, and he will give us an overview about the work we have already done and the key findings during the past months. So now, Professor Ozguler.
Thank you. Yeah, I would like to thank Professor Gong and Dr. Kanga for their support, and Dr. Oti-Boateng and Ms. Mattson for their participation and for their presentations. Well, I would like to talk about the nature of changes done or proposed in graduate attributes and professional competencies. I will also summarize the work done. Now, here are the contents of my presentation. I will not go over it one by one because of time and start right away, but I would like to first open a small parenthesis. But I think the main reason is not the emotional intelligence. Nowadays, I watch Hallmark Channel movies. In the very old times, the whole family together, we watched Turkish movies. These are the kind in which the blind girl gets operated and no longer blind marries the rich boy. And my father cried every time, you know, although the movies were really all the same. My mother just sat straight staring at the screen. So then I realized that my father is the emotional one. My mother was the rational and realistic. Now, we need more women in engineering, not because of emotional intelligence, but because they bring in a different and sober perspective. And to be honest, in order to restrain man. So, closing the parenthesis, now I will start with the definition of the graduate attributes and professional competencies. Graduate attributes is a set of individually accessible outcomes that are indicative of graduates' potential to acquire competence to practice at the appropriate level. The attributes are clear, succinct statements of the expected capability of the graduate when he or she becomes a professional. Now, professional competency profiles, on the other hand, are the elements of competency necessary for performance that a professional is expected to be able to demonstrate at the stage of attaining registration. Now, why is GAPC relevant to IEA and WFEO? Well, relevance to IEA is among the requirements of rules and procedures documents of IEA. This is like the constitution of IEA. And in there, it says the graduate outcome standard applied for accreditation by a potential signatory is substantially equivalent to that of the Accord Graduate Attributes Exemplar. So this, the potential candidate for being a signatory should demonstrate. Similarly, it's also written there that competence profiles applied by the jurisdiction of an agreement partner, a professional organization, are substantially equivalent with those specified in the professional competencies document. So the potential agreement partner should demonstrate this. Now, when we come to WFEO, in WFEO Constitution, the objective is to encourage the application of engineering and technological advancement to economic and social progress throughout the world. Now, I cannot think of a better way than participating in the development of graduate attributes and professional competencies to encourage the application of engineering today. Now, in these 2 pages, I listed the work done behind this revision proposal, just to show the extent of it. But let me just summarize this by saying that it started by a workshop held in World Engineers Convention in 2019. And then we have examined many reports, surveys, investigations. Proposed revisions have been presented at IEA meeting in 2020. And we are now in the feedback phase. Now, of course, you realize that this is the second webinar organized within WFEO, and we are still trying to collect feedbacks. I would like to say a few words about the tables that characterize GAPC, because there are 5 tables where GAPC is really developed. Table 1 is on range of problem-solving capabilities that distinguish the 4 5-year programs with engineering graduates from those that have a teaching duration of something like 3-4 years for technologists or 2 years for graduating technicians. So this table, first table, defines problem-solving capabilities for these 3 groups of engineers. Range of engineering activities is the second table, does the same thing for complex activities for an engineer, broadly defined activities for a technologist, and well-defined activities for a technician. Table 3 is knowledge and attitude profile, which can be viewed as describing what the curriculum of an engineering program must contain at a minimum. Table 4 is the graduate attributes, that is assimilated knowledge, skills, and attitudes of an engineer or technologist or technician at the time of graduation. Table 5 is the professional competency profiles. These are the competencies for a qualified engineer or technologist or technician attained not only during school education, but also through lifelong learning and professional development. Now, what a change in GA or PC implicates. When a new entry in GA table 4 is made, the following questions arise. Is this consistent with table 1, range of problem solving? Consistent with range of activities table 2? Is this consistent with the knowledge and attitude table 3? Is this attainable in the relevant program, in the duration of the program? And then, is this measurable? Is this accessible? Is this demonstrable? Measurable and accessible are more important from the side of the higher education institute program. Demonstrable is more relevant to accreditation agency because agency asks the program to demonstrate that these are attained. Similarly, when a new entry in table 5 is made, the questions arise consistent with table 1, table 2, or table 3. Is this attainable again in the relevant program because this is the first phase of the development of a professional? Is this attainable during professional development in the professional life? And then, is this demonstrable by the individual who is trying to attain the registration? Now, I would like to give an example on ethics, diversity, and inclusion. If you look at table 4, there is this Washington Accord column. I just put it here. And if you look at the ethics row, then this green color indicates the proposed changes. There is, for instance, here, comprehend the need for diversity and inclusion, technology ethics, data ethics, etc. Now, this ethics row is consistent and is supported by table 1, which is range of conflicting requirements row, and the item involve non-technical issues, for example, ethics, in that cell. And supported again by table 3, row 9, and the item ethical attitude and behavior. I have put them also here. These green colors support the green color in the graduate attributes cell. This is attainable. Now, all these attributes are attainable in all engineering programs through a variety of case study activities scattered throughout the curriculum. This is also accessible, measurable, demonstrable. Well, how? Via the documents of individual students' work done in the span of 4 or 5 years. Note that this does not necessitate a dedicated course in the already heavy engineering curriculum. Now, a few words about the difficulty of assessment. Well, outcome-based evaluation or assessment involves performance evaluation at its core. So, for example, whether a student has attained graduate attributes or not is as difficult to determine as whether an academician has reached a level of professorship or not. Similarly, whether an engineer has attained professional competencies is as difficult to determine as whether a company product satisfies, for instance, all the specifications or not. So the level of difficulty is no more, no less. We need to be aware of this while judging the appropriateness of the changes suggested to GAPC. Now, we really need your contribution in this. Well, there are 2 documents you may reach via the WFEO website. The first one gives an account of what has been done in the span of 8 months after November 2019. And also, more importantly, it has a summary of the identified main emergent points that are taken into account in the revision of the GAPC tables. The second is the tables themselves, second document. And this is a PDF document with the proposed changes indicated as I showed a sample to you. In order to add your comments, you may use the same file, a proposal to update the GAPC tables, and the tables therein, and insert your suggestions of changes in the relevant cells using sticky notes, also explanatory notes you can put. And you can send it to my email address directly. And I think in her presentation, Dr. Kanga will suggest another way of doing this contribution. Thank you very much.
Thank you, Bulent. Thank you for your presentation, and especially thank you your hard work and your working group. Despite of the COVID-19, you worked so hard and have made significant progress by working out these 2 documents, as just pointed out by Professor Bulent Ozguler, which is available in the WFEO website. And please go to the website and download these documents, give your feedback. Now we're going to ask Dr. Marlene Kanga, who has involved this work on WFEO behalf. As you know, she is the immediate past president of WFEO, and the presentation of Marlene will more focus on the table 4 and 5, talking about the changes proposed to these 2 tables. And now, Marlene, please.
Yes, thank you, thank you, Professor Gonke, and welcome everyone to this webinar. I'm so pleased to be speaking to you tonight from Sydney, Australia. And this is truly an international presentation with speakers from every continent. And I want to welcome also Dr. Peggy Oti-Boateng of UNESCO, who's based in Paris. Gail Mattson, who it's 5:30 a.m. in the morning in the USA, president of INWES. Yetunde Holloway, chair of Women in Engineering Committee of WFEO from Nigeria. Professor Leong YE from Malaysia, and yourself, Professor Gonke, in Beijing. So we are here from every continent, and I welcome you all very warmly, and all the attendees also, who are also from every part of the world. So quickly, a few words on WFEO. We are the peak body for professional engineering organizations, founded in 1968 under the auspices of UNESCO. We have some 100 national professional engineering institutions as our members, and some 12 international and continental regional professional engineering institutions also as our members, representing some 30 million engineers. And you can see our global reach in this map. We are the co-chair of the Major Science and Technology Group at the UN, and we have representation at the major UN organizations, as well as being recognized as a partner by UNESCO. A key objective of the Federation is to advance the UN Sustainable Development Goals through engineering. And our view is that we need to have more engineers with the right skills in order to do this, to develop the technologies and engineering solutions for sustainable development. And tonight's discussion on the role of women engineers is critical to achieving this goal, because women hold up half the sky, and we need the participation of women to be equal to that of men in engineering. So this project is very much about partnership, goal 17, and education, goal 4. And our partnerships, we are proud to say, is with the International Engineering Alliance. And I'm so glad to be working with Professor Ozguler and the members of the working group nominated by IEA. On our working group, we have a representative, Dr. Mike Milligan of the International Federation of Engineering Education Societies. And these are the engineering educators of the world. We also have a partnership with the Federation of International Consulting Engineers, who are the a major employer of engineers around the world. And I'm so pleased Gail Mattson is here, president of the International Network for Women Engineers and Scientists. On our working group, we also have the International Center for Engineering Education represented, a Category 2 UNESCO center based at Tsinghua University, China. And I'm also an important partner is International Science, Technology and Innovation Center for South-South Cooperation, ISTIC, Malaysia. And I'm so glad that Dato Lee Yi Chong, the honorary chairman, is listening, is attending this webinar, and I welcome you, Dato Lee. And of course, UNESCO is a key partner for the review of the graduate attributes and professional competencies. In the second UNESCO engineering report, which is due to be published in the coming year, we have a recommendation that governments, engineering educators, industry, professional engineering institutions need to collaborate to increase the number and quality of engineers. And there's a recognition that we need to work in partnership to develop the necessary international engineering education benchmarks for sustainable development, and that these need to be recognized across the world to form the basis of national education systems for engineers with the right skills, especially in Asia, Africa, and Latin America. And of course, it's very important that these attributes also attract women and girls. So a brief note on the IEA. The International Engineering Alliance is an umbrella organization that provides governance for the 3 accords and 4 agreements that provide international multilateral recognition of the graduate attributes and professional competencies. And you see here listed the 3 accords with the usual term of study, and for after work, after graduation and a period of work experience, the 4 agreements that govern professional registration. Here are the members of our working group, chaired by Professor Ozguler, who just spoke before me. And we have representatives from IEA signatories in Japan, UK, and Australia. The WFEO members include myself, Professor Wang San-Yu from the International Center for Engineering Education at Tsinghua University, Dr. Charlie Tan, President Myanmar Engineering Council, Dr. Mike Milligan of IFES, I just mentioned, but also a signatory to the IEA through ABET USA, the US accreditation body. So we are now in the consultation phase that's already been mentioned, and our documents are uploaded on a WFEO webpage, which you can access after this webinar. So in the course of the work, we recognize the need for change, and a great deal of progress has been made. These changes include the use of information technology, data, and analytics, which Dr. Peggy Oti-Boateng also mentioned, the ability to learn and adapt to new emerging technologies, greater responsibility to society and the environment, incorporating the need to address the UN Sustainable Development Goals, embedding cultures, behaviors, and values for a more diverse and inclusive profession, a broad ethical approach and responsibility for engineering solutions, the need for better online communication and consultation, which has been highlighted in the COVID-19 lockdowns. And today, global acceptance of the changes we have proposed has been remarkably fast, demonstrating that the profession itself has recognized the urgent need to change, to maintain the social license for a relevant and contemporary engineering solutions. And here's a great example from civil engineering, where 90% of the work of civil engineers is embedded in excellent codes, which has enabled that automated systems to take over much of that work, which can be done in a few hours rather than many months of labor. And systems like building information modeling, simulation and optimization enable the development of digital twins of construction projects so that every nut and bolt can be checked digitally before even construction starts, saving an amount of time and cost. So civil engineers, one of the oldest disciplines in the world, have to learn these new technologies in the digital space. But most importantly for women, the time for women is now, because engineering needs more brain power, not muscle power. And so you can see in terms of the use of digital technologies, consultation, communication, and all those areas, women can excel and make a huge contribution to engineering. So here then are the 6 areas of change, and the colors represent what I will show quickly. Accommodate future needs, emerging technologies, consider future engineering disciplines, incorporate the UN Sustainable Goals, diversity and inclusion, and intellectual agility, creativity, and innovation. I'm going to talk only about tables 4 and 5 that Professor Ozguler mentioned, the 5 tables. So I will only talk about 2, and in particular only in relation to the professional engineer. And the full details are available at the WFEO website. So the graduate attribute profile, table 4, has 12 attributes, which can be divided into 3 categories. The first is the knowledge that the engineer needs to attain during the period of study. The second is how the engineer interacts with society and considers societal impacts. And the third is the way the engineer learns to work. This is done during the university course. And here we have the graduate attribute table. We have the differentiating characteristics for a professional engineer, a technologist, and a technician. I've only shown the professional engineer category. You see the 12 characteristics are shown as WA 1, 2, 3, etc. WA standing for the Washington Accord, which I mentioned earlier. And the changes are shown in red font. The reasons are shown in this column. I didn't have time to go through all the detail, but I'll point out the key elements. We've retained the basic skills, of course, but added computing skills. In the analysis of problems, we've added the need to think of broad impacts for sustainable development. And we've added creativity, innovation, and critical thinking. In terms of investigation, we've made no change. But in terms of analysis, we've added the use of data and modeling and computational tools. And in terms of working with society and considering societal impacts, we've added the need to consult and communicate to maintain that social license. Further, in terms of human, social, and environmental impacts, we've extended those to include broader considerations that align with the UN Sustainable Development Goals. We've broadened the idea of ethics to include data and to comply with laws, and of course, diversity and inclusion. And finally, we've looked at also ways of working, a voice for everyone to work collaboratively in diverse teams in the broadest sense, not just gender, but every type of diversity. We've also broadened the idea of inclusive communication, language, culture, and learning differences. And we've added, again, creativity, innovation, critical thinking, and adapting to new and emerging technologies. In the professional competencies profile, there are 13 elements, but also divided into three areas. The first is the knowledge. So the practicing engineer will apply the knowledge learned at university and continue to grow and learn during a lifelong career. We've got how the engineer works with society, considering all the impacts of the engineering solutions that are developed in the broadest context. And we look at how we work in teams in terms of collaboration, communication, exercising judgment, and taking responsibility for our decisions. And once again, we have the differentiating characteristics and the requirements for the professional engineer I've shown here, but they are two more columns for the technologists and technicians. And the changes again are shown in red. The first major change is that we've used gender neutral language in updating this table. We've added the use of digital and information technologies, always becoming increasingly important, and the need to evaluate social, environmental, and economic risks. We've added broad impacts, use of sustainable, and the advancement of the UN Sustainable Development Goal. We've added legal, social, environmental, and regulatory issues to be considered, and compliance with national and global laws, and the ethics of equal opportunity for all, and working in diverse teams. And finally, we've looked at inclusive communication, reflecting what the graduate engineer learned at university, and the need for lifelong learning to keep up with changing technologies. Of course, the engineer has to exercise judgment as he grows, as the engineer grows in experience, and consider broad contexts of environmental, cultural, economic, and social. So those are broadly the changes. It's very quickly gone through, but you can see further on the website that the WFEO has established to consult on this important project. We welcome your feedback, and you can send them to the Secretariat by the end of August. Thank you very much.
Thank you, Marlene. Next speaker is Professor Leong from Malaysia. And she's an electrical engineer, and will talk about the changes proposed to GAPC framework and the implication for diversity, inclusion, and the fourth industrial revolution. Wei Yi, please. Wei Yi, you're muted. Wei Yi, you are muted.
Yeah. Hello, I'm Wei Yi from Kuala Lumpur, Malaysia. Welcome to our friends here. Today, I'm going to share with you the changes to the framework and the implications for diversity and inclusion, also the Industry 4.0. Thanks for inviting us to share with our friends here. Basically, the fourth industrial revolution is the ongoing transformations in the traditional manufacturing and the industry practices. Also combine the Internet of Things deployment to provide increased automations. It's also to improve the communications and sound monitoring, as well as the smart machines that can analyze and diagnose the issues without the need for human interventions. So you look at here for Industry 4.0 has been discussing for the past few years. some of the international school, primary school, secondary school, and university already included the Industry 4.0 elements in their syllabus. For instance, mobile technologies, 3D printing, robotic, big data, Internet of Things, cloud computing, cybersecurity, connective computing. So even though the primary school, secondary school, they are talking about using 3D printing in their projects. So we are thinking for this change of the framework, we should highlight these important elements of Industry 4.0 in teaching and learning and the attribute as well. Another thing we need to consider is the diversity and inclusions. This is far more than a gender. It's also include the languages, ethics, religions, perspective, the different experiences, students, graduates from different nationality, job levels, race, culture, skill, age, gender, and physical ability. We need to create a society and graduates with more diversity and inclusion. Why we need to consider the diversity and inclusions? And seems like this is the very new attributes being included in the framework. First of all, this is part of the branding as well and the reputation for the company. And we also try to avoid the high turnover rate in the company. This is a strategy to increase the profit and revenue for the company. And also we need to make the employees more engaged in their works. And also we need the graduates and employees and people from various perspective background. Basically, when we look at the proposed changes to the IEA graduate attributes and professional competency frameworks, we realize that the 6 main areas already been mentioned by the previous speaker, saying that first is the needs of the engineering professions. Second is the emerging technologies. So this is the way we need to think of lifelong learning and how to instill and include the Industry 4.0 in the syllabus, in the attributes. Also the future engineering discipline, think beyond that. We need to include the UN sustainable goals. Also the most important things, diversity, inclusions in terms of communication, environment, legal, compliance, and many, many. And the sixth one is the intellectual agility, creativity, and innovations. So these are the 6 new focus and areas we need to take care of. We look at the changes, especially going into the table 3, the knowledge and attribute profile. I realized that the diversity and inclusion, also IR 4.0, has been considered. For instance, the first one, WK1, the curriculum need social science relevant and the experience should be required. And then we look at the second one, we can apply big data analysis, especially contemporary tools to analyze the data. And then WK4, the engineering specialist knowledge also should be included in the syllabus. The curriculum should contain the appropriate contemporary courses. And the number 5, for the engineering designs, the reason for change take into considerations different domains like science, art, law, humanities, and especially the concept of SDG 12. So all this curriculum should include the specific teachings and to support the factor of design. The robotic, automations, Internet of Things could come in. And number 6, the engineering practices in terms of technology also highlighted the contemporary practice and thinking. So we realized that during all these implementations, all these changes include the complex problem solving, critical thinking, creativity, people management, emotional intelligence, judgment, and decision making. And not to forget the diversity and inclusions in the framework as well. Okay, we look at the last page, number 9. The ethic, attitudes, and behavior also included. So this is how we keep on promoting the importance of diversity and inclusions. Therefore, I would like to highlight that the changes of the framework, we need to put in the implications for diversity, inclusion, and Industry 4.0 elements. Thank you.
Thank you, Wei Yi, and thank you, especially you're linking the diversity and inclusion with the fourth, Industry 4.0. And the Industry 4.0 is transforming our world nowadays and in the future. But we really want to have these transform. It's an inclusive transform and with better diversified world. Now our last speaker is Professor Bonfield. Unfortunately, she could not join us in person, but she has well prepared her presentation in video. Now, please allow me to ask our secretariat to play the video speech of Dawn.
Hello there, my name is Dawn Bonfield. I'm joining you from the UK via video. So it's good to be here with you today. I want to talk to you about embedding diversity and inclusion, equality, diversity and inclusion into the GAPC framework. I am a member of the World Federation of Engineering Organisations Women in Engineering Committee. I'm also a Royal Academy of Engineering visiting professor of inclusive engineering at Aston University. And I work on a type of inclusive engineering that is probably not the one that you immediately think about when you think about diversity and inclusion in engineering. I think there are two aspects of this subject that I wanted to just explain a little bit further and explain what we've been doing in the UK as well to embed these aspects into our accreditation framework here. So my work is around the outputs of engineering, so trying to get our graduates to think broadly about what they need to be taking into account when they are producing their engineering products, services, solutions, frameworks, whatever it might be, but as engineers. So 90% of their time they spend doing engineering work, and it's making sure that they have this open and inclusive mindset that they can be thinking about all of these different aspects, like the protected characteristics, making sure that things are accessible to everybody, that people are not left behind, that we are taking on all of the viewpoints of the people that aren't necessarily represented very well as engineers, making sure that we create technology that is appropriate for the environment that it's made, making sure that we understand the social sciences, looking at the impact on future generations. Now, lots of these things are things that aren't necessarily included in the client brief, but nevertheless, as engineers, we need to be aware and thinking about all of these different influences on our engineering solutions that we produce. So that's the type of inclusive engineering I work on at Aston. Then in addition to that, there is the more traditional, if you like, view of equality, diversity and inclusion as a professional individual competence, if you like. So making sure that we work inclusively, so we communicate well to a variety of different colleagues and people. We work in diverse teams. We allow those diverse perspectives to come through. We manage people well. We communicate well, as I said, and we have this as our behaviour, if you like. So they're the two different aspects of equality, diversity and inclusion that I think are really important to make sure we are embedding in our next generation competencies. So in the UK, we have something called AHEP, the Accreditation of Higher Education Programmes, and we've just moved to version 4 of that. And I'm really pleased to say that both of these aspects of equality and diversity have now been built into AHEP. So we have this inclusive design aspect, and we also have it as an inclusive behaviour aspect as well. This is really pleased. I started working with the group here who are changing the GAPC guidelines globally last year in Melbourne at the World Engineering Convention, World Engineers Congress, WEC, can't quite remember what that stands for, when we had the WFEO meetings over there. And I'm really pleased to see how thoroughly this kind of mindset change has been embedded throughout this new framework. So I'm just going to share my screen for a minute and point to some of these, the variety of different ways that these have been included. Sorry about that. So I'm just going to make the screen a little bit bigger. So you can see that one of the key focus areas for change that we have here is number 5 here, diversity and inclusion. Looking at the 5, there are 5 tables in the new GAPC framework. I'm just going to go through them one at a time. You won't, of course, be able to read all of the small print, and the green text shows you where the changes are, but in the yellow boxes at the side here, I've just kind of pointed out in no uncertain terms where this has been embedded, if you like. So right at the very start, we're seeing that this inclusive mindset is here, where we're taking this wide-ranging perspectives into account, also including the future requirements for the next generation, collaboration across engineering and other disciplines, thinking about complex problems and how they interact. This reference here to natural resources, wide and inclusive perspective, awareness of the relevant social sciences and other things that are on the boundaries of engineering, as well as the engineering disciplines themselves. This creative approach, this open-mindedness, inclusive attitudes. This bit here is around our personal behaviours, our professional competencies, so inclusive teams and inclusive communications are mentioned there. And then here, design and develop inclusive solutions. Also, the language of this new framework is absolutely gender neutral. So we've moved away from the binary his or her, and we've moved to this completely inclusive gender neutral language. So yeah, from my perspective, I'm really happy that we've been able to make these changes that reflect so well the need for diversity and inclusion across all of the work that we do as engineers, both in terms of what we produce and in terms of our own professional attitude and competence. So that's all I wanted to say about that. There are my details. If you do want to get in touch with me from here to hear any more about what we've done in the UK, then please do get in touch. And thank you very much. I'm going to stop.
Thank you, Dawn. Thanks for her analysis from the aspect of diversity and inclusion to the GAPC framework. Now, we open the floor for the question and answers. During the presentation, we do receive some questions. Ivan, could you show the question list?
Yes.
And we also received some questions from the chat box. Ivan. So could you make it larger? So I see there's a good comments. Next time we're going to invite African speakers, of course. I see a comments to ask for invite African speakers. Good. So I see here a question about the geographical difference between, say, Europe, Africa, and Latin America. So when we talk about that, is I think is the question. This one, yeah. Here. Here, yes. The eighth question. It is that in the fifth table, that being implemented for gender gap, a local culture being taken into consideration. Because although both Europe and Latin America have gender gap in science and engineering, the reason are not always the same. So there's a different reason for this gap. May I ask Ms. Gail to answer this question?
Which question is that?
The question is about the different reason for the gap, for the gender gap, may rooted in the local culture and another local reasons. That's the eighth question.
Oh, the eighth question. Okay.
The eighth question, yes.
Yes, I was, okay. That's one thing that's been very interesting, being involved with the International Network of Women Engineers and Scientists, because we get input from different cultures from around the world. And it really varies depending on the culture in the different countries. And one of the things we learned with representatives from Africa is they're dealing with the various cultures, and it could be a background of their tribal cultures and the differences in tribal requirements, and the differences with people from different tribes working together, and different tribes have different expectations for women within their tribal structures. And so that's another aspect on top of society that we need to consider in terms of reaching out to different people in different cultures and getting them involved. And so one of the things that we've been focusing on INWES is outreach in that culture and bringing our information to them, but trying to translate it, what makes sense in their culture, to reach the elders and the parents and the teachers, to help them see the advantages of making changes and how it would support them. So you really have to take maybe a global program and translate it to what makes sense in that local language and culture and society structure. So that's a very good question, and it's one thing we have to be very aware of any changes we want to make worldwide. You can't use the same model everywhere. You have to adjust it for what makes sense in that local country and culture.
Thank you, Gail. I see the question 7 is how will be the implementation of these changes? Once the framework is finalized, how the local implementation in each country will be carried out. I would like to ask Professor Bulent Ozguler to answer this question.
Yes, thank you, Professor Gong. First of all, we should be aware that the attributes and the competencies, they are, first of all, discipline-free. They do not depend on the different disciplines, so between different engineering disciplines. Second, they are generic attributes that every engineer should have. So in that sense, what we really like to see does not depend on the locality, geography, etc. So these are really generic properties that every engineer should have. So, but of course, the curriculum, even the duration of the curriculum changes, and then it requires a creative design to implement these into the curriculum, depending on what kind of a curriculum you have. Well, engineering curriculums are already very heavy, so there was another question like that. How do you do this? Can I answer that one as well, Professor?
Yes,
Gong?
please, please. I saw that question is posed by Professor Durrani, Tarek
Yeah.
Durrani from UK. Yeah, please.
Yeah, this is also a very important question. Well, we are all aware that the duration of the curriculum and the its content changes from curriculum to curriculum. But if you look at the attributes and competencies, there are different kinds. There is knowledge, there is skill, there is attitude, and there is awareness. So these are all at different levels. These require different levels of implementation in the curriculum. And it just needs really a design, good design of curriculum to implement all these changes into the curriculum. I know it's a tough business, but it is possible. We are not really asking too much. When you look at them all together, it looks really horrible. It looks a lot of attitudes, a lot of qualifications, but there are ways of implementing them into the curriculum with a smart design. And that has been at the foremost in our minds when we were making these changes. Thank you.
Hello, thank you, Bulent. Here, from the chat box, I see a question talking about matching student learning outcomes to diversity and inclusion as a program learning outcome from the technical nature of our discipline can be a challenge. Any suggestion, please? I would like to pose this question to Wei Yi, and because you are going to give the professional lectures, could you have some suggestion to embed this inclusion and diversity into technical courses?
Yeah, actually, comparing to last time when I was an engineering student, I was the only one ladies in the class last time, 15 years ago. You don't know what are the men doing at the back. But now the numbers are fairly close, the ratio. Is because of, I think it's the effort of all the engineering fraternity, NGO. We keep pushing the STEM, the girls in STEM, women in engineering. I myself also chairing some of the women in engineering association. We go to the school, we go to the institution or program to promote women in STEM, girl in STEM. Even though we try to reach out to the primary school and secondary school, we try to bring to the mindset that engineering is not like just working under the sun, dealing with the cement. Engineering, they're very broad, very interesting, very exciting, very diversity. Therefore, every year, even though the Asia Pacific Nation Network, one of the members are KWSC from Korea. Every 2 years, they try to conduct the survey. We can see that the gap is getting closer and closer, but we still need a lot of efforts to promote. It's just like we need to promote and change the mindset, because when people think of engineering, they still stick to the traditional mindset. We have to keep on doing, is no ending, and we just do it.
Thank you, thank you. Does any speakers who would like to answer some questions and or to give further comments?
Yeah.
Sorry, I have, this is Peggy.
Hello, please.
I just want to follow up on the STEM education for girls. I think we need to do a lot in that area because we're still not getting the numbers. And it also boils down on the teaching of the engineering. And also, even though we have the numbers, we are not able to keep them in the profession. And as I mentioned, how would the institutions of engineering or the qualification framework for engineering take into account the reproductive, stages of women so that they can still remain in the career? Because they go out, they come back, they have to start from behind, or it's difficult for them to get in. So not only workplace, I think the whole institution of engineering, your policies will have to change. And you may also have to work very closely with the various institutions, making sure that, one, we have women in STEM, and also we'll be able to retain them in STEM. Thank you.
Thank you, Peggy. And I think Professor Bulent would like to say something more.
I would like to add a comment about the how to implement diversity and inclusion, for instance, in the curriculum. Well, I have some kind of a hint in my presentation, but you can think of diversity and inclusion ethics in the same category. You can have some case studies scattered through different related courses. Again, that requires some kind of an innovativeness on the part of the curriculum designer, but one can do that in terms of case studies, for instance. And then there is teamwork. And in that teamwork, whenever the teams are formed, you can observe the differences, not only gender, etc. But for instance, let's say in a team, some student refuses to use WhatsApp. What do you do? That's a question you can ask to the students. How do you resolve this in your team, etc.? So it requires innovativeness, but it's doable.
Thank you, Bulent. Marlene.
May I make a, yes, I wanted to comment on two things. Thank you for the opportunity. The first is that this, the changes that we're proposing to this, to these benchmarks, the GAPC benchmarks, are really changing. They will have an impact on the engineering profession in about a decade as it flows through the graduate programs and then into professional working life, because we are embedding a new culture in the way things are done. And as Professor Bulent has said, this will be in case studies, this will be in the curriculum. So it won't be an add-on. The idea is that it's changing the way we actually do. It's not going to add, not going to add layers on. I think there was a question on that. And so this is going to assist with retention, because we lose, in Australia, we lose half our women students in the engineering program itself. They leave after first year, second year, third year, etc. We lose a lot of women, and then we lose a lot of women, as Peggy Oti-Boateng has said, in the profession, especially when they go to start a family. Now, even that can be addressed, and I brought in a world first in 2008 for chartered engineers. We have chartered engineers in Engineers Australia, which is after 5 years of experience. And once you become a chartered engineer, you have to do a certain amount of continuous professional development each year. Now, I struggled to do that when I had my young children, because it was always in the evening after work. It was hard for me to work and then attend something in the evening, because I had my family. And so when I was elected to the board of Engineers Australia, the first thing I did was to address this issue. It was a huge battle trying to convince the staff of Engineers Australia. I was lucky that I had the first female president of Engineers Australia who supported me. And we got what's called the career breaks policy passed after 1 year of trying. Well, and this applies to men and women, where you take a career break for whatever reason, it averages out your number of CPD hours over 5 years rather than 3. And guess what? Men use it as much as women. So, you know, career flexibility now is being demanded by everyone, and men are participating in family life as well, you know, more and more. And so I think we, as Professor Bulent Ozguler has said, we can find creative ways to be inclusive. And this is just one example. Thank you.
Thank you, Marlene. Thank you. Gail, would you like to add some words?
Yes. I think I like the questions about how do we take this framework and roll it out to different countries. And that's one thing we're going to all have to work. I think WFEO, INWES, and various organizations, we're going to have to continue to collaborate to roll these changes out and provide materials and information to educators and different organizations in different countries on how to roll this out and how to support them. And as we've discussed, maybe one idea that works in maybe the UK or the US might not work in Africa or in South America. So we're going to have to work with the local people, the local educators and organizations, and try to figure out what will work for them. So I see the need to do more surveys in the future to find out cultural differences and how different educational structures are set up in different countries to figure out how to roll these out and how to make the changes to support diversity and inclusion. So I see still a lot of work ahead, and I'm really encouraged by the number of people involved today that we can collaborate with to do this in the future. We all want this to be successful.
Thank you. Because the time flies, we just have last minutes. Please allow me to give the last minutes to my colleague from Africa, who is Yetunde Holloway, the chairperson of the WFEO Committee for Women in Engineering, to give the closing remarks. Yetunde, please. You're muted, Yetunde. Yes, okay.
Can you see my screen?
Yes.
Okay then. Okay then. Hello everybody. Thank you for joining us today on this stakeholder consultation, reviewing the framework for graduate attributes and professional competence. One of the major thrusts is the one behind. I'll just introduce the committee briefly. We have membership across 30 or more countries that have been pinpointed here. But I know that we can just get more females all over the world to join the Committee of Women in Engineering so that we can be more inclusive and diverse. It's the voice of women engineers around the world and the Standing Committee of the World Federation of Engineering Organizations, WFEO. And we encourage females and underserved populations to consider engineering as a career. And of course, we work collaboratively with men to create a more inclusive and diverse engineering community. And we have a strategic partnership with the INWES, International Network of Women in Engineering and Science. Our main thrust is gender equality. That's the main thrust of the committee, gender equality, and our activities are strongly aligned with the SDGs, side by side with SDG 5, which is gender equality, and SDG 4, quality education. A lot has been said already, so I just want to try and put it together as much as possible. I've done this before. The voices of women in engineering must be heard in the change process of the International Engineering Alliance and graduate attributes and professional competency framework. We're probably the frontline beneficiaries or contributors to this thing. So the women should not try and fall short of contributing unless they are going to be heard. It's everybody's job, and the outcomes benefit everybody. There's innovation, greater teamwork, efficiency, and revenues. So there are outcomes and they benefit everybody. The revenues benefit us all. And we must realize that diversity is not about gender, tribe, race. It includes language, age. Anything that can make you different from the other person is something that is a diverse characteristic, and it should be considered. No opinion must be thrown under the bus. And as the Reverend Jesse Jackson said, inclusion is not a matter of political correctness. So it's not just about quotas. It is the key to growth. Growth of economies, growth of engineering, growth and growth of engineering and growth of the world. The female engineers have to be part of the transformative shift to change the profession from the inside out. And as Marlene said earlier, we won't get the results now, but we have to start. The journey of 1,000 miles starts with a single step. So we expect that in about a decade, the culture of the profession will be transformed innovatively and advance the achievement of the Sustainable Development Goals, which we expect to achieve by 2030. And the goals intend to leave the world a better place than we find it. Thankfully, we're all alive today, but COVID could have taken anybody anywhere. So we are alive today. So, but we talk about that to advance the Sustainable Development Goals we need to do. So, female engineers and STEM professionals need to be part of the change and to bridge the gender gap. The skills that are needed by anybody who is interested, who is committed to the GAPC, communication, which includes online and offline communication, teamwork, communication, clarity of information being exchanged, and stakeholder engagement, such as what is being carried out today. Today is very important because, again, women are frontliners. They are beneficiaries of inclusivity and diversity. So we benefit, and so this engagement today is very important. And the conversation and consultation continues until the 30th of August. Teamwork, of course, is working together. Everybody achieves more. So it's very important. These are some of the outcomes we expect, and the attributes also that we expect, although they've been done more formally there, but just breaking it down a bit. Critical thinking, reasoning, evaluating, assessing, analyzing to get the expected outcomes as an engineer. The ethical behavior, ensuring that the ethical behavior, the knowledge, which is from the training that you get to the specialization, going deeper to make sure that you are contributing to society. The attitude of lifelong learning and professional development. The attitudes, creativity, you only have to think it, imagine it, and it can be done. Data analytics and digital skills that are needed to make the world a better place. I'll summarize the way forward. The SDGs, they speak to social, environmental, and economic issues in society, and failure in any of these affects women and girls disproportionately. So, and of course, the engineering has to address these, otherwise it's not engineering. Everything in the SDGs speaks to these three things, and they need engineering to achieve them. The engineering, diversity, and inclusion speaks to change. Engineering females should be part of it. Policies should be enacted to retain females in STEM. And like from the previous discussion, the policies have to speak to the different countries, different regions of the world. And leadership for females is one of the things that will make change. Like Marlene said, as a leader, she was able to make a change. Time is far gone. I think I've done 7 minutes, and so thank you very much for listening. Please join the consultation. It was on the 30th of August, not the 15th of August. And that's the website that's the link for the website. Thank you very much for listening, everybody. Thank you.
Thank you, Yetunde. Finally, I would like to say, with the active participation of all participants and great contribution of the speakers, the webinar is a big success. And the presentations will be soon available on WFEO website. And the key documents about the proposed changes of the GAPC framework is also available on the WFEO website. Please go to visit the website and get more information about the consultation of the updating of GAPC framework. We need your further support to help the World Engineering Society to promote the World Sustainable Development process. Thank you so much. Wish to keep in touch with all of you, and wish you keep safe in such a very special time. Thank you. Please allow me to declare the end of this webinar.
Thank you, everyone. Thank you.
Yeah.
Thank you.
Thank you. Thank
Thank
you.
you.
Thank you.
Bye.
Thank you.